What's going on, guys? In my previous video I have explained how to convert a decimal number to binary number and also binary number to decimal number. Here we are going to see how to deal with octal and hexadecimal numbers. Now octal, when you have decimal, you know that it goes up to from 0 to 9, 1 less than the base is 10. For decimal, base is 10, so the maximum value you can have is 9 because it's starting from 0 to 9 is already 10 values. Same as that, when we deal with binary base is 2, so it goes up to 1 because 0 1 is already 2 numbers. Same like that for octal, it goes from 0 to 7 because 1 less than the base is 8. Octal base is 8, so we will get 0 to 7 is the maximum numbers. Now let's look at an example. Let's say we have a conversion. Let's say we have something like this, 296 base 8. And this question is wrong because if the base is 8, we cannot have 9 right here. The maximum number we can have is 7. Even if it was 8, it's still wrong because octal doesn't include 8. The maximum value is 1 less than the base, that is 7. So let's put 1 to do this problem. Let's put 1. Now let's see how to convert this one into decimal. To convert this one into decimal, first of all we have to look at the weight of the place. The first number, the last from the right side to left, the most right side will be the 0th place. So this will be 8 power 0, that is equal to 1, and this one is 8 power 1. Each time when we move this left side, powers will increase by 1 for the next letters. So this is 8 power 1, 8, and this one is 8 power 2, that is equal to 64. Now to get the decimal value of this one, what we have to do is we just have to multiply these values with the numbers corresponding to it. 1 times 6 plus 8 times 1 plus 64 times 2. Now 1 times 6 is 6 plus 8 times 1 is 8. 64 times 2 is 128. 128 plus 8, 136. 136 plus 6, 142. 142, and the base is 10. Okay. Now this is octal. Octal, we convert from octal to decimal. Now let's look at another number. Let's say we have 7.254, and if the base is 8, and if you want to convert this one from octal to decimal, let's see how to do that. Now let's look at the place. This one from the decimal point, okay, from the decimal point to the left side, you can see this is the first letter. So this one, since this is octal, this is 8 power 0. Now when we move to the right side, we will have after the decimal point, when we move to the right side, we will have negative power, like this one become 8 power minus 1, and this will become 8 power minus 2, and this one becomes 8 power minus 3. Now 8 power, let's put the values for this. 8 power 0 is 1, 8 power minus 1 is 1 over 8, 8 power minus 2 is 1 over 64, and 8 power minus 3. Alexa, what is 8 power 3?
The answer to your calculation is 8.3.
Alexa, what is 8 power 3?
8 to the power of 3 equals 512.
So this one becomes 1 over 512. Okay, now what we have to do is we just have to multiply these values with the corresponding numbers and add them together, and that's going to give us the decimal value for this one. So 7 times 1 plus 2 times 1 over 8 plus 5 times 1 over 64 plus 4 times 1 over 512. And if you add them together, you're going to get 7.3359375. Excuse me. Okay, let's continue. Now this is from octal to decimal. This is base 10. Now let's see how to convert from octal to binary. Let's say we have a number 216, base is 8, octal. We want to convert this one into binary. Now we didn't learn any direct method to do that, but there's an easy way. First we convert this one into decimal, then from decimal to binary is easy, because when we get the decimal number, we just have to divide that number by 2 until we get 0 to get the binary value. So in that way it will be easy. Now let's go ahead and convert this one into decimal first. 216, 8, base 8, and if you want to convert this one into decimal, we already did it here. This is the same one, we did it previously. That is 142, and the base is 10. Now to convert this one into binary, what we have to do is we just have to divide this one by 2 until we get 0. Now let's go ahead and do that. So let's separate this one. Okay, 142 base 10. I'm taking the base 10 one, and divide this one by 2 until you get 0. 2. If you divide 142 by 2, you will get 71, and the remainder is 0. 71 divided by 2, you will get 35, and the remainder is 1. And then 35 divided by 2, that is equal to 17, and the remainder is 1. And 17 divided by 2, that gives us 8, and the remainder is 1. And 8 divided by 2, that gives us 4, and the remainder is 0. And 4 divided by 2, that gives us 2, and the remainder is 0. And 2 divided by 2, that gives us 1, and the remainder is 0. And 1 divided by 2, that's 0, and the remainder is 1. And we have to go from bottom to top, and that's our binary value. Binary value is going to be 1 0 0 0 1 1 1 0, and this is the binary value of 216 base 8. So here we can write 1 0 0 0 1 1 1 0, and this is base 2. So from octal to convert from octal to binary, first we have to convert this one from octal to decimal, then we convert the decimal to binary. That is equal to octal to binary directly. So we have done this one. Now let's go ahead and deal with the hexadecimal numbers. Hexadecimal is base 16, and we have seen when we have a base, like for octal, the maximum number is 1 less than that. 7 is the maximum value octal can have. Same like that, it goes to everything. Like for decimal, the maximum value is 9, and for binary, the maximum value we can have is 1. For hexadecimal, since the base is 16, we had to have 1 less than that. So 15 is the maximum value. But here we have a problem, because after 9 we have 10. 10 is 1 0. We cannot have two numbers in a number system. So to make that one, to make it in one value, we have to do something. Let's see what is that. So hexadecimal is base 16. Now let's see how we are going to represent after 9. Like 0 is 0, and 1 is 1, 2 is excuse me 2 is 2, 3 is 3, 4 is 4, 5 is 5, 6 is 6, 7 is 7, 8 is 8, 9 is 9, and 10. For 10 we put A, for 11 we put B, for 12 we put C, for 13 we put D, For 14 we put E. For 15 we put F. Okay, this is the hexadecimal representation for values after 9. Now let's say we have A to B and the base is 16. Now let's see how to convert this one into decimal. 16 power 0, that is 1, and 16 power 1 is equal to 16. 16 power 2 is equal to 256. Now 16 power 0 is 1. 1 times B is what? B is representing 11. So 1 times 11 plus 2. I'm just converting this one into decimal. Okay. So 1 times 11 and 2 is in the place of 16. So 2 times 16. And A is 10. 10 is in the place of 256. So 10 times 256. And if you add them together, like let's multiply first. 256 times 10, that's 2560, plus 16 times 2, 32, 11 times 1, 11, and if you add them together you will get 2603. So the decimal conversion of this hexadecimal is 2603 and the base is 10. Now to convert this one into binary. Now let's see how to convert this one into binary. When we have a hexadecimal, like each value we can take 4. It goes like 8421. Okay, now first to get 3 we just have to have a 1 2 and a 1, and others can be just 0. So instead of this 3 I put 0 0 0 1 1 0 0 1 1 0 0 1 1, and instead of 0, if it's 0 we just have to have 0 everything. So okay, this is base. Let's see this one first whether it's correct. A to B 2603 base 10. Okay, now to convert this one from base 10 to this one, we cannot do like this because this will work from directly from hexadecimal. We cannot do from decimal. Okay, B is what? B is 11. Sorry. To have 11 we had to have 1 8 and 3, 8 plus 3, so 1 2 1 1, and this one is 0. So this is how we had to do it directly from hexadecimal this way, otherwise it's wrong. We cannot do it from decimal. So to convert this one, 1 0 1 1, and then 2 is, to have a 2 we had to have 1 2 and others are going to be 0. This is 0 0, so 0 0 1 0, and to have A is 10. To have 10 we had to have a 8 and a 2. 1 0 1 0 1 0 1 0, and this is the conversion from hexadecimal to binary. Okay, now let's look at another example. Let's say we have A B 7 3 C 5 and the base is 10. We want to convert this one into binary. To convert this one into binary, first let's look at 5. 5 we need 1 4 and 1 1. For 5 we have to have 1 4 0 1 0 1 0 1 0 1. Now C is 12. To have a 12 1 1 0 0 1 1 0 0. Then to have a 3 we have to have 0 0 1 1 0 0 1 1, and to have 7 we had to have 0 1 1 1 0 1 1 1, and to have 11 we had to have 1 0 1 1 1 0 1 1, and to have a 10 we had to have 1 0 1 0. So this one is 1 0 1 0. Okay, and that's base 2. This one is base 16, and base 16 to base 2. For base 10 we cannot do like this. We have to divide by 2 until we get 0 and then that value. Okay, now we have done this one. Now let's see how to convert a number from base 8 to the reason this is working for 16 is because if you add these two numbers, 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 1 is 14 plus 1 is 15. Okay, so that's why it's working for hexadecimal. Now let's see what happens if we have 4 to 1, like 4 to 1 without 8. 4 plus 2 is 6, 6 plus 1 7. So 7 maximum. Which number? Octal have 7 maximum. This one hexadecimal has 15 maximums. That's why it's working for hexadecimal. So octal has 8 maximum. So we can also convert an octal number easily to binary by using this method. Now let's look at an example of that. For hexadecimal we have 4 values. For octal we will have 3 values. Let's look at an example. Let's say we have this one, 7 4 3 2 5, 7 4 3 2 5, and the base is 8. We want to convert this one into binary. To convert this one into binary, first 5. To get a 5 we have to have 1 4 and 1 1, 1 0 1, and to get a 2 you have to have 0 1 0, 0 1 0, and to have a 3 you have to have 0 1 1, 0 1 1, and to have a 4 1 0 0, 1 0 0. To have a 7 you have to have 1 1 1, 1 1 1, and this is base 2. And that is conversion from octal to binary. Now let's see how to convert from binary to hexadecimal. Let's get rid of all of these things. Maybe this one will be helpful. Let's get rid of these things. Let's say we have a number like this, 1 0 1 1 0 1 1 1 and 1 1 0 1, and the base is 2, and we want to convert this one into hexadecimal, and we know that it goes like 8 4 2 1, right? What is the first number? 8 4 12, 12 plus 1 13, 13 is D. So this is D, this whole thing is D. And this one, we have to take 4 numbers when we deal with hexadecimal. If it's octal, just 3 numbers. Okay, so hexadecimal, here we have 0 1 1 1. It's 4 plus 2 plus 1 7, 7 right here. And then 8 plus 2 plus 1, 8 plus 2 plus 1 11, that is B. So B7D, and the base is 16. Now let's look at an octal. Octal is, let's say we have a 5751.62 and the base is 8. Base is 8, and let's try to convert this one into base is 8, or let's try a different example. Let's say we have let's look at another example. Let's say we have a decimal value like this, 53637114. Let's put a point right here, and we want to convert this one. This base is 8 and we want to convert this one into octal, binary. And we know that if it's 8, we can use this one, 4 to 1. For 4, we had to have 1. Let's use a different. We had to have 1 4 and others are 0. 1 0 1 1 0 0. So 1 0 0, and this one is 0 0 1 0 0 1 0 0 1 and 1 1 1 1 1 1, and then 0 1 1, then 1 1 0, then 1 0 0, then 1 0 1 1 0 1, and the base is 2. And that's how we can convert an octal to binary, and that's how we do that. I hope you guys find this video helpful. Thanks for watching, and if you're trying to learn digital logic design, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.